started. All right, thank you, Rob. It's awesome to be here. So just to stay in front of things a little bit, there are no product slides. I'm not wearing my carbon black shirt because I'm not doing any vendor stuff. If you want to see the full length presentation, I do have some of our product screenshots in there as well if you want to see how we do it with our product. So welcome to the presentation. We're going to talk about all kinds of ways to break things. Firstly, I'm going to go over a little bit of who I am and what I do, some of the high levels of this. What is ransomware at a high level? What is vShadow at a high level? And kind of why are we caring about it and how are they abusing it? After that, I'm going to go into how this attack actually occurs. I've cut out a couple minor things at the beginning so you can't repeat the attack because I know you. And the second thing is we're going to go over how to view this attack and actually see a lot of it happening using just native tools on a Windows system. So you can go and repeat this on Grandma Joe's system or wherever you are without fancy IR tools. Once again, don't tell my company because we build those. And secondly, and lastly, I'm going to be going over how to proactively block this using free tools that you already have. So, as Rob said, my name's Ryan Ouellette. At the time of submitting this, I ran security operations for Carbon Black. Luckily, they've allowed me to go back to being an engineer now. Now I don't have to do as much managerial stuff. I've been doing IR and forensics for about 10 years now, and as you can see from that long list of responsibilities, there's a ton of stuff that we have to do, right? For all of you that work in the security space, you have a long list of responsibilities like this. But I'm sure the majority of you can all agree that it can be summarized pretty quickly. We in the security department, that was sans friendly, I asked, we have to clean up our own messes, right? No matter what happens, we are on the hook. We are the final line to make sure that things are resolved. So what are some of the things that ransomware can do? If you look at the definition and type in what is ransomware in Google, it comes down to a definition of it is a software that stops you from regular use of your system. So it prevents you from either using certain applications, encrypting files, all kinds of different things. However, by far and away, the most evil, maniacal thing I've ever seen a ransomware do is make you complete surveys, because that is just wrong. And also, in my detonation lab that I have, I have the automated detonation going on for ransomware samples. And I couldn't figure out why this one sample just wouldn't complete running, 5,000, 10,000 runs, it just wouldn't finish ever. So I went and I looked at it manually, and I see a pop-up for SurveyMonkey. It's just coming up going, hi, what do you think of our service? You just infected my system. Why would you ask me that? Anyways, going back down to what is vShadow. So vShadow is also called shadow copies, VSS, volume shadow copy service. It's a built-in tool that allows backups in real time to occur. So you can interact with different versions of files using this, and it's built into everything from Windows Vista and above, as well as I believe there was a very late update to XP that allows it. But in this case, we're going to deal with Windows 7 because that's what most people are running. So we're going to talk about how ransomware is actually abusing this. So we're going to be looking at the very particular aspects of why ransomware is looking at vShadow and why it is such a problem. Up here on the screen, you see this is my demo system. This is a completely clean build, fresh install of Windows 7. There are no shadows already created. What we're going to do here is we're going to see how the ransomware is doing things like anti-forensics and anti-analysis, trying to make your life a lot more difficult by one, trying to find the malware, and two, trying to find artifacts of the malware to not only do other types of IOC searching in your environment, but just in general, how do I get the sample and actually do some analysis on it? So let's break some stuff. All right. For this, I have not shown you how to get on the system. You're on your own for that. And I've also taken out how to put the sample into the shadow specifically so you can't repeat it. However, Google is your friend and my enemy if any of you do that. But also, I'm not on the hook now. First things up, the first aspect of this, the malware's on your system, it has started to run. So let's kick off the process. What do? Well, we want to create a persistent shadow. Up in the top right, the thing actually works now, there's a -P option. That stands for persistent. What persistence means in this case is that it survives between reboots. And that is the full extent of how we're defining persistence for this. Another thing that you'll see is the C:/. That means that what I am doing is I am creating persistent shadow that is replicating my entire file system from root C on. You can make this any directory you want. You could be users/Ryan/whatever. That's your preference. But in this case, I'm doing the entire C drive because it looks easier on the snapshots. The second thing to pay attention to, which is important for the rest of this, is the shadow copy is called hard disk volume shadow copy 3. I bring that up because that's the name of the shadow copy we're going to be interacting with for the rest of the presentation, and that's why that name is important. So now that we've created the shadow, we need to do something with it. We need to make it accessible and usable. So that's where the mlink or mklink command comes in. This is the Windows equivalent of the symlink command for Linux. It's just creating a symbolic link. It's making something that doesn't exist sort of exist. And in this case, what we're doing is we're taking that shadow that we just created and we're creating a symlink to a directory that doesn't exist. In this case, it is in the System32 directory, and the directory is called MSDC for this example. Now, if you were doing an investigation on a system and you saw that a binary was running out of System32 MSDC, would that make your short list of things to look at? Or does that kind of look legitimate? It probably wouldn't end up on my top 5. It would be on the list of things I should look at later, but it's not going to be right there because it looks reasonably legitimate, one of those random naming schemes that they use at Microsoft. So what we're going to do now is we're going to take the malware and actually insert it into the shadow copy by dropping it in that directory that doesn't exist. And what this does now is this drops it in the root of the shadow. So that /C of the file system, that's where it now exists, the actual binary. What we're doing here is malware.exe is actually just command prompt. I just renamed it because if anybody that uses malware actually names their malware, they have bigger problems. But in this case, this is exactly what we're going to be working with. So now, as it stands, the shadow has been created, the symlink has been created, the binary has been dropped inside the root of the shadow, and now this is where the bad stuff starts to happen. You can see here that us kicking off the malware, it is actually executing out of a path called MSDC in your System32 directory, which we know does not really exist on the system. This folder was never created. There was never a make_dir command. There was never any of that stuff happening. Yet, we now have a binary running out of it. And that's because it's running in the shadow, which is symlinked over to it. Why this is important is because when you delete that shadow, the malware is still running out of that directory. So what you'll see up here is our malware.exe. You can see it running. Then I go up here and I kill the shadow, and I use just the delete shadows all command. And from that, now there's no more shadows on the system. All the shadows have been deleted. No file system artifact currently exists. Yet, if you look in your File Explorer or Task Manager or whatever you're using, you can see the malware.exe still running out of the MSDC directory. So this is kind of a neat trick because now we've removed file system artifacts. Nothing no longer exists, and now the malware is only in memory. So this is what some people are defining as anti-forensics or anti-analysis because it makes your life a little more difficult of finding the root cause. You see something running, but when you go look for it on the file system, there's nothing there. And that's a better magic trick than anything David Blaine's ever done. That includes the airplane, maybe not the elephant. So what happens? let's look at this from the host point of view, and specifically using tools that you have on the Windows system pre-existing. You can go out and spend a ton of money on fancy IR tools, and the sales guy is always going to sell you a unicorn when they really sell horses, right? So you can duct tape a plunger to that horse's head and hope that you have a unicorn, or you can start using some tools that are local and save yourself a ton of trouble. In this case, I know there's not supposed to be a ton of stuff on slides. You don't have to memorize it. I'm just showing you how many changes to the system happened when we executed this malware. There's some MD5s, there's some about 10 child processes respond, a couple different locations were created, different files read and written, etc., and different processes interacted with. So this does a lot of stuff to your system, and that's kind of what I want to get across with the slide. This is actually only about half of the stuff that was done, but you try and read it like that. Celebrite has these great little magnifying glasses that I wish I'd known about beforehand, and I would have given you the full list, so you could just hold them up and look. So after we execute the malware, this is our only indication that it happened, right, on the local system. If you don't have some kind of endpoint-based security solution, you are going to get this as your alert. Now, that sample that you guys saw, that had a score of 46 on VirusTotal, which means all the major AV vendors had a signature for it. My detonation lab has AV installed. I won't tell you which one because legal stuff, but they had a signature for it, and they didn't detect it, and it's still executed. So this is one of the growing frustrations that I have trying to actually look and detonate this stuff and work with it. But I got this nice pretty message, and what we're going to do now is look at what this actually did to the file system now that we've executed it. I have that nice pretty list that already exists of everything that I collected, but I grabbed that from my IR tool. What happens if I don't have that tool? How am I going to find this stuff on the system without any tools or support? How would you do this on a remote user system halfway across the world? You're going to have to use a command line, and you're going to have to use locally sourced stuff unless you have the world's best bandwidth or an EPL between you and that user. So let's do a couple things that you can do. Windows 7 supports PowerShell, so why don't we do one of our probably favorite Linux commands, looking for new files that are created. What this PowerShell script does is this tells me any scripts that, any files that were created on the system in the last 30 days. Now, when you deal with a bunch of malware, you know that the malware ends up changing start times, creation times, all those different timestamps that you have. However, when automated malware is running and it's not targeted, they usually don't bother. So this might not work for different samples, but this is a pretty good start. And when I kicked off this, I found a whole bunch of different binaries that created across the system. The first one is down here in the app data roaming directory. Who here has dealt with Zeus or SpyEye or any other Trojan before? Where is the first place they drop their crap? App data roaming, right? So this is very reminiscent of Trojans. I used to work at a financial institution. This is one of the first places I'd look on every single system that we suspected of compromise, looking for some type of malware on it. So what if I want to find out how bad or what this new file is? Well, that PowerShell script gives me the full path of where these files are. So I can take that list, and I found this in my research, that CertUtil actually has a hashing feature. I had no idea. So if you didn't know either, Merry Christmas. This was actually really useful to me because I was able to add it to the PowerShell script where for every file path that I got, I went and I hashed it, and I was able to get the hash out, and then I was able to use VirusTotal's API to reach out and say, what's the score of this? And create a nice little text file on the system. If you don't have internet access, you obviously can't do that, so you can go everything up to sending to VirusTotal. This is really awesome because you're able to see what the scores of these files are without using any fancy tools whatsoever. This is all native built-in functionality. Another thing that we found during that script is we have more artifacts across the system. Now keep in mind, these are all inside the shadow right now. So these don't actually exist on the file system. So how are we finding these? Well, we're looking at it and we're running those scripts trying to find these files were created at certain times. That script actually looks through the file system history. not what it currently exists. So that's going to actually have us look and find all these files that were created. First thing that was created was in the app data roaming, and then it deleted itself. So where's the next one? Well, it's in Start Menu Program Startup. Now, this is another place that I commonly find things for persistence. Who's dealt with DriedX or any of the new fancy ones that have come out recently? A lot of the different variants of them end up putting their stuff in Start Menu Program Startup. This directory path is normally used for if you want to open Outlook when you log into your system, you can drop the shortcut into there and it will open when you log into the system. It's like the GUI way of adding something to the run once directory, registry value, I mean. So next up, I'm still going through my list of all these artifacts I found that were created in the last 30 days. I found one that created a directory in root C that is the same name as all these other binaries. And if we look inside of it, there's another binary. Now, if you're keeping track, that is 4 copies of the exact same binary. I really appreciate the attacker's persistence, but that kind of paranoia is not healthy. And I hope they made enough money off of this to pay for the medication they obviously need. Then, when you're going through the system manually, now you're going to have to manually clean all of these, right? Luckily, we had that PowerShell script that tells us where all of these are. Another thing that it does is it starts messing with your registry. So what we can do is I didn't include the slide here, but there's a simple reg query command that you can run. And you can actually do the same thing. How I piped those file paths into that cert util, you can pipe those into a reg query and look for your registry for where those files exist. Are there any that exist? I added a caveat to my script where not only did it search the registry, but it also looked for if it was under the run once or run registry keys. Because I'm looking for something that was recently created and is trying to start upon either login or boot. Just an extra thing, because when we look at persistence mechanisms of malware, we're going across how many different ways can they try to continuously start. Because you're going to find 1 or 2 of these things, but are you going to find all of them right off the bat? Probably not. So we're looking for ways that they're trying to continue to start things even after they're found. Next up, since we're dealing with CryptoLocker version 1 here, there's too many to go through and not enough time. This is what I like to call the pissed list, because the longer it is, the angrier you get. And what this is in CryptoLocker 1, they actually created a registry key with all the values of every file that's been encrypted. Those jerks. Because now you can look at it and see how screwed you are. And when you end up having to screen cap this and show it to your exec staff for how compromised they are, it creates a lot of very upset executives. And I won't name who at the company looks exactly like this, but there is someone. And I just want to leave that there for a minute, just soak it in. So we've looked at kind of what happens on the system, the basic high-level attack. If you guys want to go more in depth, I have the full presentation with me that's over an hour, and we can do live demo of it and stuff later if you catch me for lunch or a beer. But in the time that we have, I want to shrink this down to detecting the attack over very commonly found things as part of this attack, right? We're no longer trying to look for symptoms. It created a file on the system. Awesome. That's a symptom of the attack, right? That's not the root cause of it. That's not how it got on your system and actually did this malicious stuff to your attack, to your system. So what we're looking here is I'm breaking the IOCs into 2 separate things. And what they are static IOCs, hashes, file names, paths, things like that, to dynamic ones like file paths and stuff. So what we're going to do here is we're going to look for vShadow. vShadow, it did not come natively installed up until Windows 7. This is kind of a debug utility. And what I've done here is I just went on MSDN and I grabbed the hashes of all the ones that I found. This is not a comprehensive list. You'll have other stuff. But I want to use this to look. What I'm going to do is I'm going to search for those hashes across the system, which I can use with the cert util feature. But one of the other things that we're going to do is, because those are static, we're going to hop into the dynamic. We're going to look for what executed here, these command line options that occurred from the script. When you execute a batch script, do you guys know what parent process that runs under? No? cmd.exe. So if we look for that parent process, we know that all this is technically a command line command. How do you search command line on a Windows system for their history? There's no, in Linux you have a bash history, you can run a history command and grep it. How do you do that on a Windows box? Who knows about DOS keys or DOS values? Yeah, awesome, 2 people. That's scary. All right, so this is kind of the utility that you use to search through your command line history. It doesn't work after reboot because nothing's saved after in memory, but very useful. And you can search for these using that key command. And you can actually see all these bash commands that occurred at the time. There we go. Next up is, we know that a shadow copy was created. One of the things that we know is this counts as a mounted device. So you can use something like Usernet or Ushare or something along those lines to find when these things were created, which is also historical. The actual paths that I have at the bottom, those are response paths that I did not change just because you can see the full pathing. For memory, for time, what I'm going to do is now I'm going to show you how to defend against this using those free tools. And I think I got 5 minutes, so I'm going to try to bust through it pretty quickly. What we're going here is 2 things. One, don't click suspicious links, kind of the thing you give out. I like to send this out to every single person that submits, that does not submit a spam message, but then I can see at the web proxy that they clicked the link. And then I love my Gandalf. So what we're going to do here is we're going to talk about the 2 main methods that we have. You have your cry method. As he mentioned, sans critical controls, they say backups. So in that spirit, vShadow. It was just used to abuse you, but you can also use it to recover. However, because they're deleting the vShadows in this attack, you no longer can. And what happens when you don't have backups to recover at, you end up having to pay the ransom, or you cry and you wait for stuff to go away. So because of that, what I'm going to show you is how to use AppLocker to actually block this. So if you have an AD domain, you have this tool already. It's free. There's 2 versions. There's a local security policy, which is just on local Windows servers, and then there's a group policy version of it that you can use. This is extremely complicated to use. It's complex. It's also, it's like trying to open a pickle jar with a sledgehammer. It'll get the job done, but it's extremely overpowered and there's going to be collateral damage. In this case, there's 2 things that I want to bring up. As in the research, I found out that you can actually use AppLocker to block DLLs, which is great. However, that will crush your system, your spirit, and your users will hate you. So instead, what we're going to do is we're going to leverage file paths, a lot of cursing, a little bit of witchcraft, and coffee to make this occur. And what we're going to create out of this, is we're going to create some block paths. So what we're going to do is we're going to take your app data and any executables in it, and we're going to set it to disallowed. And this now means no executables in this directory, and by executables, I mean by file name executables, because it doesn't check the header to find out if it's a real binary or not, to block those executables. This also means there's going to be collateral damage. Things like Firefox, Spotify, Chrome, those apps all actually use app data for updates, which is, I believe, against best practices for software development, but they can do what they want. And that's where you're going to have collateral damage. So if you end up implementing this in your enterprise, please look to see what people have installed, or you're going to have a lot of very angry people that you just broke their Spotify. They're not upset about Firefox or Chrome, but they're upset about Spotify. But things to know and lessons learned and priorities, definitely. I'd be pissed if they broke my Spotify. So in the end, this is what we're left with. We're left with a new security policy. This took a whole 10 seconds to do. So from the initial I think this machine is compromised, to creating this protection. This took 10 minutes. We got onto the system, we ran that PowerShell script to find all the files created in the last 30 days. Off of that, we then hashed them, found the ones that were malicious, found where they are throughout the system, created that nice list of things that we knew were bad. We were able to clean that system if we wanted to, or we could have just re-imaged it. But then we took those file paths and we created these new protection rules off of every one of those file paths. So in closing, ransomware is annoyingly effective, right? No one's happy about it. No one likes it. We can all make jokes about it, so we laugh so we don't cry. But in the end, what we need to do is do these proactive controls. Anything that you can do proactively will not only save your bacon in the end, but it will also make things a lot easier for you. There'll be a whole lot less to worry about, and unfortunately, there's not a whole lot you can do after the fact. So hopefully this gave some color to things you can do without spending any money. And if you want to see what you can do if you want to spend money, I have my laptop with me, and I can show you those kind of things. So my motto, flag it, tag it, and bag it, aka the double tap for any malware you find. Once again, I'm Ryan Nolet. Thank you for your time.